Alright guys, we're going to go ahead and prepare for your test on Monday here. So here's your study guide. Whatever you need help with, let's take a look at it. So number 1, use a left-hand Riemann sum to approximate the integral based on the values in the table. We're doing a left-handed Riemann sum. So the first thing that we're going to do is we're going to identify our bases of each rectangle. That's a base of 3, 3, 1, and 3. And this is a left-hand sum, so we start here as our first height. Base times height, base times height, base times height, base times height, and we don't care about that one. And so we have 9, 12, 5, and 12. If you do all your base times heights, adding all those up, you would end up with your final answer. I'm getting 38. Alright, let's go ahead and move on to our next question here. Okay, same thing, but it's a right-hand sum. So 3, 3, 1, 1. Starting on the right-hand side this time, that's my height times 1, height times 1, height times 3, height times 3, and we don't care about the last endpoint because when you're doing a right-hand sum, that one doesn't get into the calculation. So we have 5, 4, 18, and 24. $51 would be the estimated value of that integral using a right-hand Riemann sum. All right, moving on to our next question. We're going to be doing a trapezoidal sum. Okay, so we're doing a trapezoidal sum, and notice also we're doing 4 subintervals. So now there's a lot more than 4 subintervals here. So what they want us to do is they want us to actually break this apart so that you end up with only 4 subintervals. So the way that you do that is you got to find out what your total span is. We're going from -6 to 6. Well, actually, I'd prefer to subtract the bigger one from the smaller one. So how far away is 6 from -6, right? And then we want to cut that up into 4 subintervals. So that's 12 divided by 4, which is 3. So we're going by intervals of 3 then if I want to end up with 4 subintervals. So if I start at -6 and I go up 3, that's going to put me at -3, giving me a base of 3, right? Going up 3 more, 3 more, and 3 more. So I've got 4 rectangles here with bases of 3 because it asked us to have 4 subintervals. Now when you're doing a trapezoid sum, the way you do that is you do the height over 2 times the sum of the bases, right? Okay, so my first trapezoid is going from -6 to -3. Now we don't really care about any of this middle stuff here. Okay, we only care about the endpoints of the trapezoid that we care about. The 3 represents the height that we have up here. That's the height of our trapezoid. I may have inadvertently called them bases before because I was thinking of rectangles, but this is trapezoids. So the 3 actually represents a height. So you put that over 2. And we're going to multiply that by the bases of the trapezoid, which are these values here. So it's 20 plus 0. Okay. My next trapezoid will be for the next interval of 3, going from here up to here. So that one has a height of 3 as well. And we don't care about the middle ones. We care about the endpoints, which are 0 and 8. And we're just going to keep doing that for each trapezoid until we get to all of them. So for this one, we don't care about the middles, but this is my height, and these are my bases. So my height would be 3. My bases are 0 and -4. Last one. height is 3. Bases are -4 and 2. Okay, and then what we're going to do is we're going to go ahead and calculate all these. I like to leave them as fractions at first just in case we need common denominators, but let's go ahead and see what this comes to. So this is 20 times 3 will be 60 over 2. 8 times 3 is 24 over 2. -4 times 3 is -12 over 2. And then finally, -4 and 2 is -2 times 3 is -6 over 2. Now all of the numerators are even, so they're all going to reduce to nice simple numbers. So let's go ahead and do that. So I have 30, 12, -6, -3. And we just need to combine all those together to find the estimated area under the curve, which is 42, take away 9, 33. So the estimated area under the curve, or the estimated integral value, would be 33 using a trapezoidal sum. All right, so be prepared to deal with subintervals. Let's go ahead and take a look at another question. We're doing subintervals again, and this time we're doing a midpoint sum. But I want you to notice something else. You do have to, I've been kind of ignoring these, but you do need to pay attention to your endpoints. They matter. So in case you haven't noticed, we're going from -4 to 4, so we literally don't care about this stuff at all. It's like we need to pretend that doesn't exist and this doesn't exist, because we're only going from -4 to 4. So I want 4 subintervals, right? So I'm going to go from 4 to -4, right? And we're going to divide that by 4. So that's 2. So we're going up by 2's here. So from -4 up 2 puts me here. So there's my first rectangle. Next one, 2, next one, 2, next one, 2. So I've got 4 rectangles there. Now when you're doing a midpoint sum, we're still talking about rectangles, not talking about trapezoids. And how you do it is, this is the base, right? So you do base times height. Now what's the height though? When you're doing a midpoint sum, the height is the middle y value. So in this case my height is 0. So 0 times 2 is 0. Plus, next one, my next rectangle goes from -4 to, from -2 to 0. And so the base is 2, the height is 5. And that would be 10. Next rectangle, going from 0 to 2, base is 2, height is 0. We got another 0 height there. And then finally, last rectangle going from 2 to 4, base is 2, height is -4. There we go. So putting these together, we end up with 6 as our final answer for the estimate of this integral with a midpoint sum of 4 subintervals. Okay. Next one. Here we go. So we're looking at properties now. So they're telling us that the integral of f from 0 to 7 is equal to -5. The integral of f from 7 to 10 is 8. And the integral of g from 7 to 10 is 3. They are asking us here, what is the integral of f from 0 to 10? Well, the integral of f from 0 to 10 is the same thing as the integral of f from 0 to 7. Plus the integral of f from 7 to 10. Going from 0 to 10 is the same thing as going from 0 to 7 followed by 7 to 10. It's just you're putting 2 integrals together. And so we know from the top up there that that piece is -5, and we know from the top that 7 to 10 is 8. So the final answer there would be 3. Okay, next one. Let's go ahead and take a look at this. So for this one, we're going to apply a few properties as well. First of all, we don't really care for the limits being backwards. We like the smaller one on the bottom. So we need to reverse that and put a negative in the front. The next thing is we're going to distribute this integral in to each one separately. Notice that when I did that, I carried the negative with it as well. So we have this integral, right, plus this integral, right? But the negative integral kind of got distributed to both. So we have that expression there. I think it would be easy to forget to include this negative right here. But you have to include that because we're distributing this integral with its negative to both pieces. Now the next thing we're going to do is when you have a constant multiple of a function there, you can pull it out to the front of your integral there. And a plus a minus is just minus, so I'm just going to go ahead and combine those into a minus now. Okay, now we know that this piece here, the integral of f from 7 to 10, is 8. So this piece here becomes negative 3 times 8 minus this piece here, which we know is 3. So we have negative 24 minus 3, which is negative 27. Okay. Next question. So once again, we're going to go ahead and distribute our integral here using our properties. So it's going to be the integral of f from 7 to 10. Now, for this piece here, it's pretty straightforward. We have the answer up here, it's 8. However, for this piece here, we have a property. You could do this in a variety of ways, but the way we learn in class is we realize that when you have just a number here, it's a rectangle where this is the height, and the base is 10 minus 7. And so we have 8 plus 3 times 3, which is 9, total of 17 is our final answer there. I mean, the other way you guys could handle that integral, if you wanted to, I mean, I'm not a big fan of memorizing things. So memorizing that as another rule can be a little tedious in the long run. I mean, the old school way to do it would be to literally integrate this, which would be 3x, and then plug in the 10, and then plug in the 7 and subtract them using the first fundamental theorem of calculus. And what do we get out of that? That would be a whole different answer, wouldn't it? That'd be 9. So now that's the same answer that we get whenever we do our shortcut, which I share with you, thinking of it as a rectangle where you have your height, right, multiplied by the difference of those two. You still get 9. It's just that, you know, one's faster, one's longer. This one's easier probably just to figure out, but hard to remember to do it. I'm sorry, no, easier to figure out, right, but easy to remember to do. This one here, you have to take time to memorize it, but it's faster. So whatever works for you. Let's go ahead and take a look at the next one here. All right, so let u equal x minus 3. So I'm giving you a hint for this one. So if I let u equal x minus 3, then they're basically telling you we want to do some u substitution. So we're going to find the derivative of u with respect to x. The derivative of this is 1. And that means that if we get the dx by itself, by multiplying both sides by dx, you end up with du equals dx. So now we're going to come back over here and we're going to rewrite this. We're going to replace x minus 3 with u, and since du is equal to dx, I'm just going to replace dx with du. But we also have to fix these, okay, our limits. So in this case, x is 10 and x is 3. When x is 10, u equals 7. And when x is 3, u equals 0. So if x is going from 3 to 10, that's the same thing as u going from 0 to 7. So basically we're rewriting this integral, and from there we would go ahead and evaluate this. So now I understand this says u, but it doesn't really matter. It's the same function and we're still going from 0 to 7. So 0 to 7 is negative 5. All right, next question. Okay, there's a ton of questions for this one, and we'll just kind of take each one as we go. All right. So for these problems, you'll probably want to just kind of figure out the areas ahead of time. You don't necessarily have to do it that way. It's just that you'll probably need to. Now on the real AP test, you know, they're not going to ask you to do everything under the sun with this function, so you might only have to worry about one question at a time. But for us, let's go ahead and just go through and find all the areas first. So I want to find that one, but before I begin, like I said, let's go ahead and just find all the areas. So my first piece that I see here is I've got a negative 2 in here, right? And then down here in the semicircle, that's half of a circle, correct? So we have pi r squared, and a half circle is always divided by 2. The radius of this half circle is 1, so that little piece in there is pi over 2. But since it's under the curve, it's negative pi over 2. Okay? Let's go ahead and take a look at another part of this now. Excuse me. All right. This little triangle right here, oops, I erased. Let me back up. This little triangle right here is it's a triangle, so it's 1/2 base times height, right? The base is 1, the height is 1, so that's 1/2 basically, but it's under the curve, so that's negative half. This other little triangle next to it is above the curve, and it's exactly the same. It's a positive half. Let's see, next part. This next interval here from 0 to 2 consists of a miniature little rectangle here and a quarter circle. So the area of a quarter circle is pi r squared. Now the radius is 2, so 2 squared over 4 for a quarter circle is divided by 4. Well, 2 squared is 4, the bottom is 4, so they just cancel. So the top of this thing is 4. I'm sorry, pi. This little piece in here is 2. So that whole interval from 0 to 2 is 2 plus pi, basically. All right, the next interval is kind of awkward and crazy, but we can do it. Here you go. So we have another little rectangle right here. That's 2. But we also have this little wedge. We've talked about this wedge quite a bit. So the way that you find the area of a little wedge like that is it's basically the area of a square minus the area of a quarter circle, right? Now the side lengths of this wedge are 2 by 2, right? And that's what the square is, and that also happens to be what the radius of the circle is. So the area of this square here is 4. And the area of this quarter circle is pi radius squared over 4, and these just cancel. So the area altogether we're looking at here is 4 minus pi for the wedge. Just for the wedge, though, okay? 4 minus pi is the wedge, and then underneath that we have 2. So altogether on that interval, 4 minus pi plus 2 is going to be 6 minus pi is the total purple area there under that curve from 2 to 4. Okay, the next thing we're going to look at is from here to here. That's an area of 4. Okay, so we've got all of our little area pieces figured out here. Now we can go through and just start answering the questions. So I'm going to start with part A. Alright, so with part A, it's telling us to go from -4 to 0. So basically we need to go from the red region up through the blue region. So the red region that we have up here is the first part is -2 minus pi over 2. Then we have the green region, which is -½. And then we have the blue region, which is +½ That's going from -4 to 0. So red, green, and blue there. These cancel out, and so you could just assume your answer there is -2 minus 2 pi. All right? That was pretty simple. Let's go ahead and take a look at the next one. Okay. Part B. Part B asks us to go from 4 to 2 for our function. I'm sorry, from 2 to 4. So that's the purple region only. So in the purple region, as you guys can see, we have the little rectangle on the bottom, which is 2, and then we have the wedge on the top, which is 4 minus pi. So altogether, that little region is 6 minus pi. Okay, part C. Part C is asking us to find the integral from 8 to 0. Now that's backwards, right? We don't like the bigger limit on the bottom. So the first thing I'm going to do is I'm going to rearrange this so the 0 is on the bottom. And when you do that, you have to put a negative in the front. And so now we're going from 0 to 8. So I'm going to make a pretty wide set of brackets here because that's a lot. So 0 starts with the pink region on this graph, and it includes the purple and then the peach colored there. So the pink region consists of a quarter circle and a rectangle. The quarter circle is pi, and then the rectangle underneath of it is 2. And then we have the purple region, which is a wedge, which is 4 minus pi, with a rectangle underneath of it, which is 2. And then finally we have the peach colored region, which is 4. So let's go ahead and combine all those together. First of all, notice the pi's go away, and then we have 2 plus 4, 6, plus 2 more is 8, plus 4 is 12, and we have a negative in the front, so the final answer to that one would be -12. Okay. Now we need to see the next question, which is kind of hiding, so I need to make this smaller for a minute if I can. All right, the next question is the integral of f of x plus 2 from 8 to 4. Try to get this size right here again, if I can. Oh, I don't think it's going to let me get it right. Oh well, I'm going to have to delete everything. All right. So we are doing the integral of f of x plus 2. And I believe it was, what was it again? It was 4 to 8. Okay, so for this one, we're going to start by applying one of our properties here, which tells us we could just take the integral of each of these pieces separately. Okay, so as for this piece here, we're going from 4 to 8. Well, that's pretty simple. That's just the rectangle that we had there. That's 4. Plus, here we have to use another one of our properties. This is a rectangle as well, where the height is 2. And the base is 8 take away 4. And so we're looking at 8 there. So that's 4 plus 8, which is also 12 in this case. Okay, next question. We're doing the integral of 0 to 4 for f of x plus 2, and we're letting u equal x plus 2. All right. So, okay, so now they told us, hint, let u equal x plus 2, which we saw that earlier in our work today. So we're going to have this. So the first thing we're going to want to do then is we're going to want to rewrite our integral. It's going to become f of u, and then we're going to replace dx with du. And then we've got to redo our limits as well. So when x is 4, if I plug in 4 here, u is 6. And when x is 0, I'm going to plug in 0 now, u is 2. So we're basically finding the area under the curve now from 2 to 6. Okay, so from here to here. Now, our pieces that we had before, if I remember correctly, because I had to delete mine, this one here, from what I remember, was 4 minus pi. And then the one underneath of it, and they go together, was 2. And then this little wedge, or this little rectangle right here, is 2. So what we're looking at then here is we're looking at 4 minus pi plus 2, which is 8 minus pi, is our total area under the curve for that particular region. Okay, let's take a look at yet another question now. We're finding the integral of the absolute value of f of x from negative 4 to 0. Okay, fair enough. Now when you take the absolute value of your function, now let's think for a minute here. Some of you guys had a hard time with this on your quiz. We're taking the absolute value of f of x. Now f of x is the y value, so it's the same thing as taking the absolute value of the y values. Now if you take the absolute value of the y values, any y value that's negative will become positive. Well, on this graph, the only y values that are negative are here. So they're all going to become positive. So if it helps you, what you can do is you can actually just redraw the graph. Okay? You could take this dot here, it has a y value of negative 1, and just move it up here. Same thing here. And then you could take this dot here, which is negative 2, and move it up here to the positive 2. So instead of having your half circle be down there, your half circle is now here. And then you have this little line, right? So it's going to get flipped over here to like that. So basically, when you take the absolute value of a function, it just takes whatever's below the x-axis there and flips it up into the positive region. Makes it all positive. So what they want us to do on this problem is they're asking us to find the integral. Let me double check one more time on the interval here. They want us to go from negative 4 to 0, right? So negative 4 to 0 of the absolute value of f of x. Okay. So we're going from here to here. So we have a rectangle, we have a half circle, and two little triangles that we need to put together. So we found this earlier. This was pi over 2, and it used to be negative, but now it's positive because of the absolute value flipped it over. This is 2, and both of these are a half. And now everything's positive, right? Because we're dealing with absolute value. So basically what this ends up being is pi over 2 plus 2 plus a half, and we end up with pi over 2. This makes 1. If you add that to the 2, you get 3. Okay, so that would be pi over 2 plus 3. All right, we have one more question, I believe, for this one. Find the average value of f of x on the interval from -4 to 8. Okay, how do you find the average value of a function? The average value of a function is given by this expression here. Oops, that is wrong. Back up. So what we're going to do is we're going to find the area under the curve first, and then we're going to multiply it by that. So in this case, the b and the a, if we're going from -4 to 8, just basically means they want to know what's the total average value from beginning to end here. So we're going from -4 to 8. And so there's our setup. So this piece here becomes 1 over 12. This piece here is an area, right? So we're going all the way over. So we have this piece, which is -2. This piece, which is negative pi over 2. This piece and this piece, both of those are halves. The first one is a negative half. The next one is a positive half. Then we have a quarter circle. And then we have a rectangle. Then we have our wedge, which we said was 4 minus pi. And then we have a little rectangle underneath of it. And then finally we have the last rectangle, which is 4. Okay, so let's go ahead and put all this stuff together. So notice the halves cancel out. That's nice. The pi's also cancel out. I'll do that. Then we're just left with some numbers. So the 2's here can cancel out. That's good. So now I see what we're left with then here is we have negative pi over 2. And then over here we have a 4, a 2, and a 4. That makes 10. But we don't want to forget about this 1/12 in the front. We're going to go ahead and distribute that in. If we distribute that in, you're going to end up with negative pi over 24 plus 10 over 24. No. Sorry, not 24 on the bottom there. It's actually going to be, if you multiply 10 by 1 over 12, you get 10 over 12. So I mean, now we could leave our answer like that. I wouldn't. I would say the answer this should be at least reduced. So one way the answer could be written is like this. However, you could actually go another route with this and get a common denominator. The common denominator for these two fractions is 24. So if I multiply the top and bottom of this one by 2, you end up with negative pi over 24 plus 20 over 24. And so your final answer would be 20 minus pi over 24, if you want to put the positive one in the front anyway. So either one of those two boxed answers up there at the top are good solutions. Whether or not they would want you to common denominator just kind of depends on what you see as your options in the multiple choice. Okay, so that takes care of that one. That was a biggie. Let's go ahead and take a look at some more here. So you'll also be asked to deal with some half circles. This is an integral of a half circle. When you're doing these types of problems, when you're looking at this, it's plus or minus square root r squared minus x minus h squared. And then, let me erase that, I went too far. And then plus k. Now the h and k make up your center of your circle. Notice that the h will be changing signs, the k will not. The r represents the radius, not r squared, but the r, right? And then if it's a positive in the front, it's the top half of your circle. If it's a negative, it's a bottom half. So in this case, we're looking at a bottom half circle with a radius of 10. And since there is no h and k, the center is 0, 0. So the first thing we're going to do is we're going to graph this. 0, 0, 10 to the right, 10 up, 10 left, 10 down, and we actually only need the 10 down. We didn't need the 10 up because it's an upside down circle, so it looks like this. So there's our picture. Now if I wanted to find the area from 0 to 10, pay attention to your limits. We're only looking at this much of the circle, so it's a quarter circle. Now the area of a quarter circle is pi r squared over 4. The r in this case is 10. So we would have 100 pi over 4, which reduces to 25 pi. However, keep in mind this is under the curve, so our answer is negative 25 pi. Next one. Same type of question here. In this case, I have a radius of 9. My center is going to be 410. So let's graph that. Matter of fact, I think I'm going to need to make it a little bit taller. Okay, so my center is 410, so over 4, up 10. Should be right about here. And then my radius is 9, so I'm going to go out 9 to the right of that. I'm going to go 9 to the left of that. So this is at negative 5, by the way, if you go 9 to the left of 4. And if you go 9 to the right of 4, that's at 13. And then we're also going to go 9 up. So puts me here, and then my half circle looks like this. And they want me to find the area under that curve. Now when you're finding the area under that, and by the way, we're going from negative 5 to 13, so that's the whole thing. But we're going not only need to find the half circle, but you also need to find everything else underneath of that half circle. So it's a rectangle and a half circle. So the rectangle here has a height of, what was it, 10, and a base of 18. So 10 times 18 gives you an area of 180 for that rectangle. Now the half circle on the top is going to be pi r squared over 2, because it's a half circle, so it's 81 pi over 2. And they're both positive values because they're above. So the total area under the curve for this particular function would be 81 pi over 2 plus 180. Okay, now we get to do some more fun stuff here. Integration of a piecewise function. So when you're integrating a piecewise function, you have to break it up into its pieces. We want to integrate this function from negative 7 to 3, but along the way, the pieces split. So as we're on our way from negative 7 to 3, we have to stop at the x value of negative 3, because at that point, we switch from this piece to this piece. Okay, so basically when you have a piecewise function, you have to break your integral up into two pieces. So we're going to go from negative 7, the first limit, to the first breaking point, which is negative 3. The next one will pick up where this one left off at -3 and end at the final point, which is 3. Now, if we're from -7 to -3, those are x values that are less than -3, so that's for this piece here. And then if we're doing from -3 to +3, those are numbers that are greater than -3, so that would be this piece here. All right, so at this point we have some fun things that we get to work on here. We're going to have to integrate these now. And before we begin, I like to set it up like this. Okay. Actually, before we even get there, we need to do this. So let's go ahead and integrate these really quick. My bad. Should have done this first. All right. So if you integrate this, you're going to add 1 to the power. So it's going to become x squared. And you're going to divide by 2 also, which makes, so if you divide this by 2, it's already being divided by 2. So if you divide by 2 again, that makes it 4. You multiply the bottom number by what you're dividing by. Plus, this one, when you integrate the 9, you just get 9 over 2x. As for this guy here, it's -3x. Nice and simple there. Okay, so now we're going to come up here to this part. Okay, so the first thing we're going to do then is we're going to plug in the -3 here. If we do that, we're going to get -9 over 4, and then plug it in here. And you know, I realized I have a little bit of a boo-boo here. This was not supposed to be a plus. This was supposed to be a minus. Let me fix that. Oops. Because when you integrate this thing, it doesn't change the sign. It stays a negative. So so now we're going to go ahead and plug in the -3 here. So you're going to have a -9 times a -3, which is going to be a positive 27 over 2. Then we're going to repeat for the next number. Plug in the 7 here and here. That's going to give us -49 over 4. And then plus 63 over 2. And now we're going to repeat all that for this other integral over here. We're going to plug in the +3 to get -9. We're going to plug in the -3 to get a +9. The next thing I advise doing after that is distributing your negatives along. Get rid of all this stuff. I put the answer up here to make sure we end up with the right spot. Let's see. So after we go ahead and distribute, let's go ahead and do that. We're going to distribute the negative in here. So the -9 over 4 stays the same. The 27 over 2 stays the same. But when you distribute this negative in, you end up with a +49 and a -63. Adding a -9 is just -9, and then subtracting 9. So we get rid of our parentheses by distributing negatives. After that, I would advise you to combine any fractions that are the same, like the 9/4 and the 49/4 there makes 40/4. We have the 27 over 2 and the -63 over 2 have a common denominator. We can combine those. What does 63 take away 27? Oops, I wrote that backwards. All right, so we got to borrow 36. So we end up with 36 over 2, but it's negative, right, because the 63 was bigger. And then we have the 2 9s here, which is -18. Luckily, these two just kind of simplify. This is 10, and this is 18, and this is 18. So putting all this together, we get our answer there, which is -26. Okay? Let's go ahead and take a look at another one here. Integrating absolute value functions. So before you begin integrating an absolute value function, you need to rewrite it as a piecewise function. Okay, so we have 4 blanks we need to find. The first ones we're going to find are what the breaking point is, where it switches from one piece to another, and you get that by setting the inside function equal to 0 and solving. So the breaking point is 1. Okay, now the next thing we got to do is we got to do a number line test. And we're going to pick a number to the left and a number to the right of our breaking point. So 3 times 0 is 0, take away 3 is negative 3, and the absolute value will change the sign. So for anything that is less than 1, we're going to change the sign. And whatever happens, we don't really need to calculate this, because once you've got this side done, the other one's the opposite, so there's no change here. So for anything where x is greater than 1, we will not change the sign. So for our expression here, 3x minus 3, we're going to write it twice, but for the one that is less than negative 1, we're going to change the sign. Okay, and so there's our piecewise function. Now that we've rewritten it as a piecewise function, you're going to go ahead and handle it the same way you handled the other question. All right, so after that, guys, it's pretty much the same thing that we did before. We're going from negative 4 to 2, but our breaking point is 1. So negative 4 to 1 is the top half. And then 1 to 2 is the bottom half. Okay, once again, we're going to integrate. And then we're going to go ahead and plug in our numbers. And this is the setup I recommend before you do that. And so plugging in 1, we end up with negative 3 over 2 plus 3. Plugging in negative 4, we're going to get, let's see, negative 4 squared is 16, times negative 3 is negative 48. Divide that by 2, and you're going to get negative 24. Repeat here, negative 12. All right, just double checking my work right here. There's a ton of places to make mistakes. Just a moment. 16. Okay, moving on here. Let's go and do the next one here. We have plugging in 2. We're going to get 2 squared is 4, times 3 is 12, divided by 2 is 6. Plug it in here, minus 6. That's just going to go away. We can ignore that. Plug in 1. You can get 3 over 2. Plug in 1, minus 3. Okay. After we plug in, we go ahead and do any distribution. Remember that? We distribute. So we have negative 3 over 2 plus 3 in the first parenthesis set, and then distribute this in, and we're going to get plus 24 plus 12. We got rid of this because they were opposites. We'll distribute this one in, and we get minus 3 over 2 and plus 3. We're going to go ahead and combine our like terms here. So these two go together. Those are negative 6 over 2. And then putting all the numbers here together, we have 36 here. Plus 3 is 39. Plus 3 more is 42. Now luckily this simplifies into negative 3, right? So we're left with negative 3 and 42, which is 39. Let's go ahead and cross our fingers here and hope that it worked out good. Yay! Okay. We're going to do one more like this, but we're not going to take it all the way through, and you're not going to be expected to do that on your test either. This one, all I want you to do is to set it up as 3 separate integrals. So as soon as you get to the place where you've written it as 3 separate integrals, you're good to go. Okay, so the first thing we're going to do is we want to set the inside equal to 0, right? On this one, you have to factor and solve. Before I upload, I'm going to fix these limits. I'm going to change the limits to -5 and 0, so this works out better for us. Okay, so now we do a number line test, right? Anything to the left of -2. If we plug in, like, let's say a -3. So we have 9 take away 15. Oh, I'm being silly actually. Let me back up a little bit. I just realized I wrote my number line wrong. The -3 should have been here, and the -2 should have been here. Now in retrospect, I think I'm going to change my mind, and instead of even starting on this side, I'm going to start over here. I'm going to pick an easy number. I'm going to pick 0. I'm going to plug in 0. Just pick an easy number to plug in. Usually 0 is the easiest. So all this is going to go away, and we're going to be left with the absolute value of 6. That's no change. So for anything that is greater than -2, there's going to be no change. And after that, it just kind of flips back and forth. So that means that for anything that is in between -3 and -2, we will be changing. And for anything that is less than -3, we'll have no change. And so writing this as a piecewise function, then we have the following. We have all things that are less than -3, all things that are in between -3 and -2, and everything that is greater than -2. And we decided only the middle one is going to end up changing, and so this expression here is going to all be opposite signs. And then the other two will just be normal. Okay? So to take this to the final point, basically what I want to see is that you guys noted how to do this part. You're going to start at your lowest endpoint. You stop at your first break point, and you know what function to put there. This one goes here because anything that goes from -5 to -3 is less than -3. The next one will pick up where this one left off, and it will end at the next breaking point. And that function is there. And we're using this function because, oops, no x there, sorry. Because anything between -3 and 2 is represented by that inequality there. And the last thing we're going to do is we're going to pick up where we left off at again, and we're going to end at the final endpoint using the last piece. So this is what you'll be expected to do in your test, is just how to get to the point where you can rewrite it as an integral of 3 separate pieces. Okay? Not going to ask you to go ahead and do all the fundamental theorem of calculus on there, just too time consuming. And the other 2 problems kind of cover that basis anyway. Okay, let's go ahead and take a look. This one's asking us to find the average value of the function on the given interval. So the average value theorem is this, as we saw earlier in our video today. So if I were to plug all this stuff in, it would look like this. So 3 minus 0 is just 3. Now, let's go ahead and integrate this function. So what is the integral of 2x plus 1? That would be x squared plus x, going from 0 to 3. All right, so we're going to plug in the 3. It's going to be 9 plus 3. We're going to plug in the 0, which is just 0. And so what we end up with is 1/3 times 12, which is 4. The average value would be 4. Next question. Same thing. Average value theorem states that 0 minus a negative 3, integral of my function from negative 3 to 0. So we have 1 over 3 again. Now what is the integral of this thing? Well, the integral of e to the x is just e to the x, and the constant also just stays the same. So the integral is literally the same thing as what was there, but don't think that's always true for everything. I've seen some of you guys doing that, and that doesn't work. You actually have to integrate, but in this case we actually just kind of end up with a nice convenient thing. So plug in 0 here. E to the 0 is 1, so we're left with, well, let me get my setup here first. So plug in 0, we get 1. Negative 3 times 1 is negative 3. And then we'll plug in 3, and we get negative 3 e to the negative 3. All right. So at this point, we kind of have a weird situation here, just a little bit of algebra to deal with. So we have negative 3. Distribute your negative. Now, as you guys know, anything to the negative power can be written like this, where you move it to the bottom, right? Okay, the next thing that we're going to do is I'm going to go ahead and combine this and this together to get a common denominator. So I'm going to put this over 1, and I'm going to multiply the top and bottom by e to the 3rd. And so now I have negative 3e to the 3rd. I'm going to combine the tops together here now, and we'll have one fraction. Now we still have this 1/3 on the outside here. So this 3, so a few ways you could do this, but basically the 3 is just going to reduce the fraction by 3, right? Now there's a fast way to do that, but I'm going to show you guys the longer way, but I mean basically some of you guys might already see what to do. If you know the faster way, go for it. But right now if we multiply that in, we have the following. Right? Now the next thing I'm going to do is I'm going to go ahead and factor a 3 out on the top. So I divided a 3 out of both of the terms there. And the reason I did that is so I can cancel those out. And so here is what your final answer would look like. They might write it like this, or since this is a negative, they might write it like this. Either way is fine. Okay? Let's see how they wrote the problem real quick. Yeah, they just left the negative e in the front. And they also put a decimal value there, but probably won't be needing a calculator, so we'll leave it. Okay, next one. We're being asked to find the derivative of this function, but notice that this is an integral function. Now, whenever you have just a number down here and just a variable of x up here, then when you do the derivative, it's just the second fundamental theorem of calculus, which basically states your answer is this, but instead of a t, you have an x. So, rejoice. It's an easy problem. Know it. Next one. Here's another one just like it. We have a number on the bottom and just an x on the top, so the derivative, according to the second fundamental theorem of calculus, will be this thing here, but with an x instead of a t. Okay, but then we get into problems like this one, where it's no longer just a number on the bottom and a single variable on the top. now I've got an x cubed on the top. And in that case, you have to look at what we learned on Friday, how to take the integral of a composite function. So what we learned about this is that if f of x is equal to the integral of 1 over x minus 3 cubed, then according to the second fundamental theorem of calculus, the derivative of f is just the integrand, right? But since we have limits involved, it's going to be a little bit different. So let's see how that is. So first of all, if I were to integrate this, I'm going to end up with some unknown function f. And since we're doing a definite integral, we're plugging in the top limit and the bottom limit. Okay? The next thing we're going to do is we want to find the derivative, right? So the derivative of my function will be the derivative of this. Now when you take the derivative of this, this is a... trying to back up here. It's not letting me. Okay. So the derivative of this is going to be a chain rule. So you have the derivative of the outside function, which is big F there. And the derivative of the inside is 3x squared. Minus derivative of the outside times the derivative of the inside. Now this is just going to end up being 0. So we're left with this. So that means the derivative of my function then is going to be 3x squared. Now instead of f prime of x cubed, since f prime is this, we're just going to rewrite that. But where the x was located, we're going to plug in the value x cubed. So if we were to simplify this, this is going to end up on the top of the fraction. And on the bottom, we're going to have x cubed minus 3 squared. Now, there is a shortcut rule for this, so you don't have to go through all those acrobats to get there. I'll show you guys the shortcut, and then you guys can use the shortcut to do the next problem, which also looks at that. So the shortcut rule is this, is that if you have f of x is equal to the integral of g of x with, let's just call this j of x and h of x here and here. So then the derivative will be the following. What we found out was it's basically just the g function with the top plugged in minus the g function with the bottom plugged in. But since it was a chain rule, you have to multiply each one by the derivative of the inside. So there's kind of our little shortcut there, which we're going to use on the next problem if you're interested in using it. All right, so if you're fast forwarding through this video and you just got to question number 20, backing up to number 19, you might want to see where this formula came from, especially if you were absent on Friday. But anyway, so here's how it goes. In this case, this top piece is going to play the role of your h. The bottom piece is going to play the role of your j. And this thing here is going to play the role of the g. Okay? And so the problem is asking us to find f prime of x, the derivative of this thing. So f prime of x then is going to be the derivative of h, which is this in this case, multiplied by my g function with the h function plugged into it. In this case, this is my g, and that's my h. So I'm going to be plugging this into this function, which would look like this. Now we do the next one. Minus the derivative of the j function, which is this one, so that's just 1. times the g function with j plugged into it. So this is the g, and we're plugging the j into it. So that would look like this. And we're just plugging in the j function, which is x. Okay, so let's simplify this up a little bit. We have 2x, and then negative x to the fourth, plus 6x squared minus 6, minus negative x squared plus 6x minus 6. We can go ahead and distribute this negative here, and we can also distribute the 2x here. So we're going to end up with negative 2x to the fifth plus 12x cubed minus 12x. And distributing the negative inside the second set, we end up with plus x squared minus 6x plus 6. And then any like terms we have, we would want to put them together. So these can go together. Negative 12 and negative 6 makes negative 18. So I'm going to put the x squared first, and then I'll put the negative 18x there. And there it is. So if you can simplify or you have to look at your answer choices, because once again this is a multiple choice test. You'll want to look at your answer choices, see how they write their answer. Yeah, they go ahead and simplify it all the way. I think on the last question they would not have simplified it any more than I had it. Yeah, so they just leave it like that. So they're not expecting you to do foiling of any kind or stuff like that. It takes too long. But all right, let's do another one. And once again, we're going to be following that same formula there. So once again, if you're just fast forwarding through the video and you didn't see numbers 19 and 20, you might want to see what I'm doing with this formula here, especially if you were gone on Friday and that formula looks like Spanish or something to you, or, well, imagine a lot of you guys speak Spanish. Maybe like we'll say Latin. How's that? Looks like Latin to you. It's so foreign. Okay, so let's see here. So in this case, the h function is x squared, the j function is x, and the g function is cosecant squared. We're being asked to find f prime. And according to our little formula up here, the way you find f prime is you multiply it by the derivative of h, so the derivative of this, times the g function, which is cosecant squared, with the h function plugged into it, minus the j function's derivative, which is 1, with the g function once again, oops, squared it too soon, with the j function plugged into it. Okay, if I were to simplify this, it would look like this. I mean, there's really not much more you can do with it. So that's the best way to write the answer in my opinion. Let's see how they would write their answer with the software here. Yeah, same way. So we're good. Can't see it. I'll clear it up here for you. All right. I think that's the end of our study guide, if I'm not mistaken. Nope, one more. Okay. Interesting. All right, last question here. They're giving me a graph of f prime, but they're asking me stuff about f, and that means we're going to have to integrate, because the integral of f prime is f, right? Now, they're asking about specific values of f, though. Like they're telling us that f of 2 is 3 and f of 5 is what we're trying to find. So the two x values that we care about in this problem are 2 and 5. So what we're going to do is those are going to be the limits that we're going to be integrating with, okay? Which means that when we integrate this according to the fundamental theorem of calculus, it's going to look like this. So this side over here, we're going to evaluate this by doing geometry on our graph. We're going from 2 to 5, so from here to here. And what that is, it's a one triangle and one rectangle. So that's 2 there, And the triangle is 2 times 2, which is 4. Cut in half is also 2. So 2 and 2 make a total area under the curve of 4. We want to know what f of 5 is, but we know what f of 2 is. F of 2 is 3. So if I want to figure out what f of 5 is, all I have to do is add the 3 over here, and I've got my answer, which is 7. Okay? So, there you have it. I think that does it, guys. I think that'll end our study guide. We'll do the FRQ and the review portion of this test probably on Thursday. Okay? We'll see you guys in class Monday.